Smriti, hello.
Yes, sir.
Okay, ready, na? Fine.
Yes, sir.
Wait for another 6 minutes, then we'll start.
Okay, sir.
At TCS Hyderabad. Mrs. Smriti is an expert coding with Java and Python and has extensive knowledge in data structure, algorithms, machine learning, natural language processing. She will be sharing her insight on the physical aspect of machine learning from translating concepts to code. Get ready for an insightful and engaging workshop. Ma'am, now you can start the.
Welcome, Smriti. Now you can start. Share the screen. I have already given the permission. You can share and start.
Yeah. Thank you, sir. Thank you, Anshika, for the warm welcome. And good afternoon to everyone. I hope people are active. I understand it's post lunch and people might be feeling sleepy. But don't worry, and stay tuned for a really exciting session because it's less of theory and more of implementation. And as most of us are students here, I believe it is going to be extremely beneficial to all. So I'll start first with a quick introduction of myself. Anshika already said it, but my key research area interests are natural language processing, machine learning, and recently generative AI, all thanks to Satya sir first. And I have been working in a startup since initially from January, and I was working as a generative AI engineer there. And now I've joined an TCS Hyderabad as system engineer, working in AI for streamlining and automating the retail process and manufacturing industry. Okay, so that brings us to today's topic. Let me share my screen just a minute.
Yes, it's
I
visible.
hope my screen is visible to everyone and I'm audible clearly.
Yes.
Yeah. So, as the topic of the session is machine learning from concept to code. In the morning, you've had two sessions, and I believe you already have a background knowledge about what is machine learning, what are its different types. So, I'm not going to recap or brush up through those things. We'll move on to the agenda for the session. First, I've already given the introduction. Now we'll go through the basic concepts which I'll be focusing in the session. And then we'll go through a hands-on or a practical implementation of what we are going to, what we learned in the entire process. And then we can have a Q&A discussion if needed. So what basically I'm trying to achieve in this session is that to show you a realistic depiction of how you formulate a machine learning project, starting from the very basic ideation process to gathering the data, to processing the data, to creating the model and actually deploying it. Okay, because a lot of machine learning projects just get stuck at the Jupyter notebook and they don't move forward. But if you want to showcase your projects, if you want to showcase what you have built, it's very important that you have to bring it out of your Colab or Jupyter notebook and you have to showcase it and you have to deploy it. So that's what we'll be focusing today. We'll start from scratch building an ML project and we'll go to making a web app and see how to deploy it. So you can showcase the project very easily to the entire world. So let's start with the process. What happens is that the very beginning, you have to identify your problem statement. What are you trying to achieve? Whether you are creating a spam email classifier or a credit card for fraud detection or facial emotion recognition or any chat GPT clone kind of thing, you have to first define your problem statement. Next, move on to data collection. Data is open sourcely available, whether you want, you can find it in Kaggle, and there are so many other repositories which are offering you data. Otherwise, if you have went through a research paper and you want to simulate or create the similar work on the similar data set, you can email the researchers and get access to the data. And now once you have the data, what you have to ensure is that for a machine learning model, we have two types, supervised and unsupervised. If you're focusing on supervised learning, you have to ensure that your data is properly labeled and validate the data. We'll learn more about it in the next processes. Then for the data preparation part, we first have EDA, exploratory data analysis, where we need to see whether the data set has any missing values or null values. And in the data processing step, we are gonna fill in the missing values and replace the null values with some concrete values, which doesn't hamper a model performance. And certain times what we have is that our data set is imbalanced or there is not enough data. So we go through data augmentation, in which we create samples of the data so as to increase either the data size, or if you have two classes, let's say A and B, and A class has 50 samples and B class has 100 samples. So it is imbalanced. So you can resample the 50 make copies of the 50 samples of class A, so that it is at par and now the class is balanced and your model will give you a good result. Then comes to training the model. Before training the model, you should know what all models are available. By models, I mean the ML algorithms which you have come across, whether it is decision tree, random forest classifier, ensemble techniques, or the basic naive Bayes classifier or anything. So you have to try, and there is no way you can know which model will perform the best for your data set. It is mostly always hit and trial, and you have to try with different algorithms and check what is suitable for your data set the best and proceed with that. And after you build the model, you have to see, at first you might get an 80% accuracy, but you should not be disheartened or be overexcited that you got 80% accuracy. Your model might be capable of increasing the accuracy, or in certain cases, the model bluffs and get an 80% accuracy, which might not be the real thing. So you have to validate your model performance and then tweak certain parameters to get your desired results. This is in sync with the evaluation process, where you are using different evaluation metrics, whether it is accuracy, F1 score, precision, and your confusion metrics, and so many things in which you can use it to evaluate the your model performance. Okay. Then there is, after you see your accuracy report, you can analyze whether you might have 10 features in your data set, but not all features might be relevant or might not be contributing to your model's performance. So you have to also analyze whether all the features which you are there in your data set are relevant or not. Okay, and if in case there is any wrong predictions, which you can get to know from your confusion metrics, then you have to reevaluate your models or retrain your models to achieve your desired results, so that you get a good accuracy, which is not only a high value, but also it is having good precision and recall. Then comes to the production part, which I was emphasizing on, that is deploying your model. It's not always that whenever you build a model to show it, you'll open your VS Code or PyCharm, or you'll open Jupyter Notebook to see that, see, this is my model, this is my accuracy. That is okay when you are working in group projects within your teammates, but when you want to showcase what you are going to build, you should have a proper user interface or interactive interface in which the user or the person whom you're showing can interact and understand what you have tried to build. Okay, because something which is present in a IDE is not productive, is not a product. Okay, when you are working on any projects, you will always have to think in a real life scenario kind of a perspective, because why are you building this? Who is this meant for? What is the future of your project? Is it just something you're doing for your grade CGPA, or is it something which can be carried forward, if it is more scalable and It's something innovative. Okay, you guys have opportunities of fellowships, hackathons, in so many ways in which you can take it to the next level. And this part of your projects is very important. It's not about what you did and what you showcase and but what your model or what your project is capable up to, how much it's scalable. That is what is going to set you apart from the normal crowd. Okay, because there are so many people who can get the code from GitHub or from YouTube or anywhere else, or just take it from your friend and implement it, run it in your own local machine. But to analyze the business use case of it, or to get a future perspective towards this, what is going to set you apart from the normal crowd. Okay, and after that, sorry. Okay. Excuse me for that. Yeah, that's what I said. Even after a product is launched, if you must have seen, you are getting Android updates or iOS updates. So even after something is launched and deployed, it can need some improvements, maintenance, and updates. So that's why we always have to keep a check on the performance of the model, and if needed, we have to retrain it. That's why this is always a continuous process. A model which gives initially 90% accuracy might not give it throughout its lifespan. It will need retraining, it will need new data to stay updated. Are you guys here with me? Can you hear me? Can I get a response?
Yes, yes, yes.
Yes, yes, we can hear.
Yes, ma'am.
Yes, yes, yes.
Yes,
Yes, ma'am.
Do you have any questions till now? Or am I going through, or can you keep up with the pace? Am I using very unfamiliar terms?
No, ma'am,
No,
it's fine.
It's fine, right?
No, ma'am.
So,
fine.
okay, then let's go to the hands-on part. I have prepared a small implementation of any ML model, which we can use to see how we are selecting a problem statement. This is a hypothetical problem statement which I've chosen so that it's funny and interactive for you all. But I'll tell you how to search for problem statements if you're looking for inspiration. That will come in the later part of the discussion. So this is a problem statement which we have picked up. A lot of you must have heard of the Titanic movie. Almost everyone must have known about the Titanic movie, right?
Yes.
Yes.
So there is a simple machine learning problem whether to predict that a passenger who is onboarding or who is in the Titanic ship has the possibility of sinking and drowning or surviving when the Titanic hits the iceberg. Okay, that is a problem. And inspired from that problem statement, we have a spaceship tragedy. Okay, now imagine that you are astronauts and you are set out on a space mission, and it's a group of astronauts and spaceships which have started, and you have to reach from planet A to planet B, but due to certain unforeseen circumstances, some of your spaceships uh, happen to go through some mishaps, and you enter into an alternate or a new dimension. You must have heard of black holes and everything, so you don't know what can happen. Okay, so this is our problem statement. We have to see and predict whether, based on the passengers' details and the spaceship details in which they were traveling, we have to predict whether they have been transported to an alternate dimension or they did survive and reach back to the own planet. Okay. So it has 2,500 records, which is good enough to start a small machine learning project. But when you are building it for a real life application, you need more than that. It's always advisable to go for more than 10K records. Okay, and we have around 9 features here. And this is basically a binary classification. Binary, why? Because our output is either yes, they survived, or no, they didn't survive. Yes, they got transported to the alternate dimension, or no, they didn't get. They are safe and they went back to their home planet. So this is a binary classification problem. What are the features in the dataset? We have passenger ID. We have the home planet, that is the source from where they're traveling to, which is Earth, Mars, Europa. Then there is cryosleep. Cryosleep as in either you can be active during your journey or you can be in a sleeping pod. So this is kind of like that. If your cryosleep value is yes, then you are in a sleeping pod and you are not active during your voyage. Then there is spaceship side, just like airplanes. We have spaceships have different, majorly 2 different parts, port or starboarder. That depends on where the passenger is seated in the spaceship. Then passenger age, which is 18 to 55. And whether the passenger has opted for VIP service with special food privileges and lodging privileges or not. The destination, that is where they are traveling to, Moon, Uranus, Mars, Saturn, and the spaceship in which they are traveling, Nautica, Voyager, or Aryabhata. So what we are going to do in this project is, first we are going to perform exploratory data analysis, then we are going to do data pre-processing, then we'll prepare our data and the model. We'll also see how to train and evaluate the model, and finally we will launch, we'll go to deploy the model and create a web app for it. Just a minute, let me reconnect to the collab file. If you guys are joining from your laptops, you can even code along simultaneously if you want to.
Anyone interested to do it simultaneously with ma'am, they can start if you have laptop, okay, with you.
The data sheet, please. Record.
Okay, just a minute. I can share a file here, right? I'll share the data set. So I need admin permission to share the file.
No, okay. So which file you want to share? I think
A CSV file. Should I mail it to you, sir?
yes, you can mail me. I can
Just
put it in WhatsApp group. Okay. You can mail me.
Okay, sir. Just a minute. Sir, I've shared the file to you. Guys, let me know once you receive the file, and then we can start.
In which mail, Smriti?
Sir, your official kit mail address.
Okay, fine. Okay, yes, I got. Let me share it in WhatsApp group.
Yes, sir. Meanwhile, you guys can open your collab notebook.
Yeah, it is shared. You can find it from the WhatsApp group just created.
Is everyone familiar with Google Colab, or should I share you the link to open it?
You can check your WhatsApp group to find the dataset.
Yes, please check and download the data set.
I've got the data set.
Yeah. So download it, and once everyone has downloaded, just ping it in the group once you have it on your local system. So then we can start. Everyone is able to log into their Colab account. Or if you have Jupyter Notebook also installed, you can use that. But sometimes you might need certain libraries which are not available. You have to install it. That might be a longer process. So it's always advisable to use Colab. I'll also share the link to my Colab file so that it's easier for you to copy paste and write the code instead of just typing it in.
In chat box, you can share the link.
Yes, sir. But just because you've got the code, that doesn't mean that if you are planning to do it along with me, don't stop that process, okay? Is the Colab file accessible? Are you able to access it? Or do you need some access permission?
No.
You can access it, right?
Yeah, we have access it.
Yes, ma'am.
Yes.
Okay, great. So what you have to do is that once you have a new notebook opened up, there is a folder option at the left side. And there is a folder called sample data. And once you go to sample data, there are 3 dots here. You can click on upload and upload your data set. After you upload your data set, you can find it here. Is everyone able to upload your data set?
And will you please repeat once?
Okay. Once you open a new Colab notebook, this you won't get obviously the codes. You will just get an empty Colab notebook. On your left side, there is a folder option. There is a files option you can see. And once you click it, there will be only one folder for you all. So that will be called as sample data. You have to click in, go inside, and there are 3 dots here. And you have to press that. There is an upload option here. Once you click on upload, you can find that you can upload your data set there. Mahima, could you follow?
Yes, ma'am, it's done. Thank you, ma'am.
Okay. So for everyone is able to load the data set, right?
Yes, ma'am.
Yes, ma'am.
Or you guys, for easier, if you don't want to type in the code, what you can do is you can create a copy of this file. You can, create a copy or just, oh, it's okay, fine. You can copy it in a new notebook and just run it simultaneously with me. Okay, so I guess you're good to go and we'll start. So first part will focus on exploratory data analysis. Why is exploratory? What is exploratory data analysis? Why is it important? You need to know your data set. For example, if you are working on spam email classification, you need to know how you want to build the model. You need to have a data set. You need to have what kind of data set? You need to have a list of emails. You need to have the content of the email, and you should at least have a label whether it is spam or not spam. Then you can train a model which will analyze it, and then learn how to classify whether an email content is spam or not spam. Email content is just one of the factors. Sometimes from the email address itself, you can know whether it is a spam or a marketing ad or something like that. So there is another factor, a feature, that is email address. Then there is email content, and there is the subject line. So there are so many features on which can be used to train a model which is aimed to build a spam email classifier. Similarly, for this, we have a number of features which we discussed previously. We are going to use the pandas library to build a data frame out of this data set. Okay. And if you're not able to find this path, you can find it right here. Once where in the sample data, once you can see your data set is loaded, there are 3 dots here. You can copy file path, copy the path from here and paste it here. Okay. So from pandas library, we are going to use the read CSV function to load the CSV file as a data frame. And how does the data frame look? A data frame is nothing different than a tabular format or a CSV data. The original data set, as you can see in Excel, you can open any CSV files. This is your data set. We have the passenger ID, we have the home planet, we have cryosleep, whether they are in cryosleep mode or not, in which side of the spaceship they are traveling, what is their age, whether they have opted for VIP facilities or not, what is the destination, what is name of the spaceship, and whether they are target value transported, whether they are transported to the alternate dimension or not. So the same features you can view by this command, that is df.head, and I've mentioned 20, but this command is used to fetch first 20 records from the beginning of your CSV file. You can change it to 10 also, and you can view. So it is going to give you 10. Okay, now there in Colab you also get an option in the extreme right side of the corner. This is a table view mode. There is also a chart view mode in which you can directly get certain kind of graphs for analyzing your data. But we are not going to go use that option. We'll code the graphs ourselves. Okay. And by viewing the sample data only, you can see there are certain text fields. Okay. The passenger ID is a numeric data type. The home planet and all these things are strings. This is Boolean data type. This is important for your analysis, what type of data you're holding. Because all machine learning models do not work on text data. We have to convert it into numbers or numeric vectors. Then only the model will be able to work on it. Okay, so we are going to display the information about the dataset by using df.info. Here you can see all the column names, which are our features. Okay, and you can see how many entries are there. There are 2,500 records, and what is the data type of it. And you can also get a statistical report of the dataset by using df.describe. You can see what is the count, what is the mean. But now you might have a question that why are we getting the statistical report for only passenger ID and age? Because only these two are the numeric entities, in numeric features in our data set. The rest all are text features. That's what I was saying. All text features don't get processed. That's why we have to convert it into numeric form, which we'll do it in the later steps. Then, if you had noticed, there are certain missing values, as in the passenger age, you can see there is a null or a not valid value here. Okay, now when you are having a data set, it's very important to check whether it is having null values or missing values or not. Because if a passenger age is also a very important factor for predicting our output. And if we are having missing data here, it will affect our model performance. It's the same for any other feature also. Is it the same for everyone? The data set which I sent, is it not, are you not getting this output? Hello?
Yes, ma'am. I think you sent final spaceship dataset and not
Okay.
the spaceship dataset.
I think they are getting confused due to the different file names. But guys, the data is same. Just have a look on it.
Yeah, so once you run the code, I think
Yes,
it's
ma'am.
the same
The data
data
set is same.
Yeah, don't worry. I
You
had
have to
two
change
files,
the
that's
path.
why I renamed it. Okay, don't worry, it's the same data set. Okay, so we'll continue. So yeah, I was saying that's why it's important to check for whether we are having all datas are present or not, or whether we're having certain null value or missing values. How can we check for that? You don't need to write any codes, because whatever process we are following here, that we can manually write a code, a different function for it. But we already have certain libraries in Python, which makes it way easier for us to code it. That's why the difficult part of creating any ML project is not the coding part. You can get help from Stack Overflow, GitHub. It's very easy. But you should know what you are doing and why you are doing it. Okay, so we are going to use df is null. If there are null entities, then we need to count how many null entities are there in each column. Okay, and when the report is generated, we can see there are 16 null entities in passenger age. Okay, so this just checking whether there are missing values or not, that is a part of exploratory data analysis step, and how to handle missing values will come in data pre-processing. But so that we don't forget it in later steps, I included it here only. Okay, so if there are missing values, how are you going to handle it? There are so many ways in which you can tackle a missing values. What do you think if you get a missing value? Because if there are missing values, it's almost like it is of no use. This entire record is of no use for us. So how do you suggest we handle it? Is anyone interested to take a wild guess? You need not be correct. Just suggest an approach.
Ma'am, either by mean or a median of the complete.
Putting the mean, median, or mode value.
Yeah, very much correct. You can use mean, median, mode, or if you have a very large data set, you can even skip the entire row. Okay, that is a very basic way of doing, but it's always better, and the most appropriate way of dealing with it is just like you guys suggested. Use mean, median, or mode value to replace the missing value. So we'll go and calculate the mean age. Okay, once we have calculated the mean age, then we'll replace all null values with the mean age values. And that is what you can see. The mean age of the passengers is 36.47. And once we replace it, we can see we had a null value at number 10, right? For passenger 10. Now you can see that for passenger 10, we have 36.45. So that means all the null values are now replaced by the mean age. So that is your first milestone which you achieved in this project. You successfully dealt with a missing value, you found out a missing value, and you replaced it successfully with a significant value. Now, next, what other problems can be there if there is a very large data set? Because we are dealing now with only 2,500 records, we don't have any hardware restrictions or any infrastructural restrictions. But imagine, and this is text data, so it is a small file. Imagine if you are working on image data or audio data, or even if text data, but you have more than 1 lakh files, then it's going to consume a lot of your memory, and you might not be able to run the model only on a CPU. You might need GPU acceleration for it. Okay, so what happens when we have large number of data? A lot of time there are duplicate entries also. Now the duplicate entries won't be significantly contributing to your model performance, so we can always skip that. That's what we'll search for here. We can search for duplicate entries, luckily we don't have any in this data set, but if you have them, you can drop them. Okay. Now we had searched for missing values, we searched for duplicate entries. Now let's see what type of values and how many values or what categories values we are having. The most important feature or the target value is transported parameter. Okay, so let's see how many we have of transported. So we are going to use Seaborn library to create a plot of the data set where we can see how much. You can do this in Matplotlib also. It was simpler in Seaborn, that's why you use Seaborn. Okay, so you see we have more than 2000 files for true class, but we have less than 500, around 400 files for false class. Now, this is okay if you already know that most of, if your expected output is also favoring true class. But sometimes what will happen is that this will lead to overfitting or underfitting a model. Do you know about overfitting or underfitting models? Hello.
I think they know. In morning only the ma'am told.
Okay.
If you know or not, underfitting,
Not
overfitting.
ask you to explain it. Just say that whether you know or not.
Yes, yes. Writing. Actually, I have unmuted this, muted everyone here.
It's okay, sir. Okay, so great. So if the model is overfitting, then one of the dominant class is overpowering the output of the model. If we have more of true files, it's highly likely that in our output we'll also get true, true, true. So it's important here that we used class imbalancing problem. This comes under class imbalancing problem. You have to rebalance it by using resampling. There are two ways in which you can do. Either you can reduce the size of the dominant class, or you can increase the samples of the less dominant class, or the scarce, or the class which is having less number of attributes. So any of the two ways can be followed, but here we are going to skip it. We'll see it. We'll see how it is impacting our model in the later turn, which is why it's important for real life scenario. Okay. So here in this project, we are not going through it, but if you want this, you take it as a task for yourself when you're trying this on your own, try to resample it and see how you are getting an improved accuracy. Okay. Then there is a correlation matrix. This, I don't know if you have gone through the theoretical concept of it. If not, in simpler terms, it tells us what is the correlation between two features, whether they are related or they are not related, whether it is contributing, whether the relationship is meaningful and relevant towards our predicted output class. Okay, for now, just take it that lightly. Okay, after and we did only one kind of graph here. What you can do is you can make more graphs and see the comparison between this target feature with all our rest of the features. That is, create a graph which contains passenger ID versus transported. Create a graph to see the count of home planet versus transported, which will give you an idea and an analysis that how many people from the home planet Earth were successfully transported to the other dimension, or how many people from Europa got stuck in the other dimension. So it will help you get an overall idea about your problem statement. So you can, that's a task for you to be done. You have to make comparative graph analysis. That is another step in exploratory data analysis. After that, now we'll move on to data pre-processing. Now what we see is that the passenger ID is not a very important feature. That is, the passenger ID is not contributing enough to the whether a passenger is transported to the alternate dimension or he or she got stuck Okay, so what we can do is we drop it. When you have a large number of feature vectors, just like the dataset size, the size of the feature also matters a lot, because a lot of times the overfitting and underfitting problems are also arising due to huge number of features. Especially in text data, you have to be very careful about what is the size of your feature set. There are a number of techniques which are used for dimensionality reduction or feature reduction. Okay, and usually in most real life scenarios, in smaller projects, you won't come across the problem of feature or dimensional reduction. But if you have a very huge data set, we are talking about more than 25,000 records, then you might have to use a dimensional reduction. In there is two ways to approach it. Either you can just drop in some columns or some features which are not relevant, just like we did for passenger ID here, or you can create new vectors. You can combine two features to create a new feature and use it for your model. Okay, so it all depends upon what the problem statement is and how your model is performing. That you can only analyze once you have create a base model. You have to go and create a dry run first, just like when you are doing programming. First you do whatever question is given to you, you do a dry run, you go with a basic approach, then you try to fine tune it and come up with a better approach. Okay, that's the same thing with machine learning projects. Okay, you need to have a basic run of it so that you can see what is going wrong, and then only try to put in more steps. Because if your model and there might be a huge data set, but it might be a simple problem. It might not need so much of data pre-processing or feature extraction or feature fine-tuning. But if you are doing it from the beginning, it will hamper your model performance. So always go with the basic approach first, and then see your model, evaluate your model performance and the model metrics, and then go on to whatever new things you want to add it to it. Okay. So if you remember in the beginning, I told you that we cannot work with text data. We have to convert it into numeric data. Boolean values get converted automatically, but for other text values, we need to convert it ourselves. So this process is called as encoding in very basic terms, but the process which there are two ways. There is one hot encoding, then there is label encoding. In this, we are going to use label encoding process, which is very simple. What it's gonna do is, like, suppose for home planet, you have Earth, Mars, and Europa. So what it's gonna do is, first it takes everything in alphabetical order. Let's say, then it becomes Earth, Earth, Europa, and Mars. Now it will assign 0 to Earth, and for Europa it will assign 1, and for Mars it will assign the value as 2. Okay. Similarly, for other textual features or string features which are having string values, it will encode it in a similar way. So we need to see which columns are having our textual or string data type, and we'll encode it into numeric forms. So we are using this label encoder. This is just like a class. You're creating an object of it, and you are using it for home planet, spaceship side, destination, spaceship, and transported. Remember, it's very important that you have to use it on your target variable. That is very important. So after we are using label encoder, you can see for the home planet, it's easier to compare. See, you had Europa, you had Earth. Okay, so you have 1, 0, 1, 1. Sometimes if it's not in alphabetical order, it depends on which platform also you are using. It behaves a little differently. So, but basically it will assign one unique number to what all unique values, string values you have it. So we have 100. It starts from 0, that is important, just like any array indexes. And we have it for spaceship, home planet, destination, and spaceship name. So all the values are now encoded, and the dataset is now ready to be used for a ML model. But there's still something which we need to do before we put it or use it for making any ML model. That is, sometimes when you're downloading datasets, you might get it in two parts, for training set and test data. But if you don't get it, that's why you have to split the data. Some of the data will be used for training and some data will be used for testing. Now, why is it important that we need to split the data set for testing and training? I want an answer from you guys. Why is it important that you have to split the data set for training and testing? Why can we not use the entire data set?
Ma'am, to evaluate the model performance.
Okay, how?
Ma'am,
How is it
we
going
check
to
for
work?
the true positive and the false positive rates, like AUROC curves and the confusion matrix for that.
Okay, okay. For simpler terms, for people who are not familiar with ROC curves, and whatever he said is completely correct. But whenever you are doing something, you need a benchmark to see whether it is working properly or not. So imagine that this 10 records are in your training set. You'll train the model. Okay, now the model knows this data. The model has seen this data. So obviously, if you are putting any of the values from these or any of the records from the training data, it will obviously give you a correct response. But what we need to see is that whether the model can work on new data or not, how well the model is working on unseen data, the data which it has not come across during its training phases. When you are learning for your semester exams, you have your books and everything, whatever syllabus is given to you, you can obviously know the topics from those syllabus. But in an exam, if you're getting a topic which is not discussed in the class or out of syllabus, if you are like when you are practicing C program, Java program, the teacher or faculty cannot tell you hundreds of 300s of codes to practice. They give you 5-6 example codes which you practice. The rest, it depends on your understanding. Now, if they give you a new question, you should be skilled enough to solve it on your own. Okay, this is the same thing with the model. So we have to divide the data into training and testing set. The model should train on the seen data or the training data. Then we need to see what the model has learned and how well has it learned by testing it on the testing data. So we'll separate first our features and our target labels. The X contains your features and Y is your target labels. Then we'll split it using test train split. Like I said, whatever function we are using right here, you can write it manually. But we have sklearn library, which is helping us to do it in just one line of code. So what we are going to do, we are going to split the features and the target values. In what size we are going to split it? That is 0.2. That is 80% of your data will be used for training and 20% of your data will be used for testing. And this is random state, which is used to ensure that sometimes you have similar data, your data is present in a similar pattern. Let's say first 5 will be of if like we are having here passenger, let's say home planet. The data might be in such a way that from 2500 data, the first 100 records, the home planet might be Earth. The next 1000 records, the home planet will be Europa. For the rest of the records, it will be Mars. If we split it 80 and 20, the right from the middle, we take first 80% for training and rest 20% for testing, you might not get the Mars data in your training set. Okay, but we have to give the training data should be as realistic as possible, right? So what the random set ensures is that even if the data is not jumbled up, it will ensure that it is taking a proper real and it is taking samples from each and every part of the data set. Okay. That is how we are preparing our training and testing data. After that, we are going to train the ML model. We are going, in this example, we will be using a random forest classifier. I think you have gone through decision tree and so many other algorithms in your previous morning sessions. In this session, for this project, we are working on random forest classifier. This might not be the best model for this task. Okay, it's just that I tried 3-4 models in the morning and this gave me a good result. So we will be seeing this one. This is again a task for yourself. You can use decision tree, you can check for ensemble learning methods. Okay, you can even combine 2-3 algorithms, 2-3 models, create a pipeline and use it and see how it's performing. Okay, and after that, we are gonna train the model on this. And we are going to, after training it on the training data, we're gonna test it and we are going to predict labels for the unseen data. Okay, after that, you have your report, your model evaluation or model the evaluation metrics, which I mentioned before, that is precision, recall, F1 score, support. We have to see this and analyze whether how is our model performance. 82% accuracy is basically means that it was able to correctly classify 82% of your unseen data. Okay, similarly, you have other, and it's not important that for every ML project, you need to have a good value of precision, recall, F1 score. For certain, depends on what your objective is. Here we just want to correctly classify our results. So maybe focusing on accuracy is enough for us. Okay, but for some other reasons, the way he mentioned, we need to check about our true positives, false negatives and everything. That's why we have to build the confusion matrix and check it. Then now that your model is ready, we are going for what was our step? We were going to, we had defined the problem. Now we have prepared the model. Now we are going to deploy it. Deploy it as in we are going to create a web app out of it. Okay. So for creating a web app, what we need to do is we have to save this model. The training the web app part I will do on my local system, because for Streamlit, using Streamlit here, it requires some other extensions. What you can do is you can create a simple HTML, CSS, JavaScript web file or web interface, use this model there itself. But for simplicity and for ease of use, when you have less than just 10 minutes or 15 minutes, you need to wind up your project, the best thing to use is Streamlit. Okay, so this is what we are going to make to showcase our model. Okay, so all the features which we are using, we are going to take it as user input. Then we are going to predict whether the person survived or whether it got transported to the alternate dimension. Okay, now before doing that, we need to save our model because we are training it into clouds. There are different reasons for training it into cloud. A lot of times we don't have the hardware requirements on our local system. A lot of times it's easier to collaborate because now 2-3 people can work on the same notebook here, but please don't make changes into this one. Okay, and so it's better. And for cloud, here you can see you have tools, change runtime. Okay, now we are using Python 3. We are working on CPU. But if you have to build a bigger models like LLMs for generative AI, which we use, or the one which ChatGPT uses, then you'll have to use GPU. There are less options available in the basic plan. If you go for premium, you'll get more also. So that's the best part, that you can, it's always easier to train on cloud and then do the local, the user or web app part in your local system. Okay, so for that, we are going to use a library called Pickle, and we'll save our model in a pickle format. Pickle format is like the way we have, what is it called? We have different data structures, right? We have stacks, queues. This is a different ways of storing data. Similarly, Pickle is also one of the format in which you can, whatever model you trained on this data, you can store it in the form of a pickle file. Okay, once you run this file, then you can find this model underscore pickle file here, which will be generated in your folder section. And you can go here and download it. Okay, so till now, does anyone have any doubt, or could you follow through the process?
Ma'am, how we will generate the model.pickle file if we are doing these things in our local machine?
If
Ma'am,
you're
if
doing
we
it in your local machine, there is no need to do the pickle file generation part. You can, if you want to save the model and use it for some other cases, then you can just save it, or I'll show you in the next part when you are using it in the local system, right? If your model is in the same directory, or even if you are training it in the same local system, you might not need to save it as a pickle file. Okay, it will work for you. Because it is
okay,
these two things I'm doing in a different environment, it is important for me to save the model and then use it in my local system. That is how we are using, Chat GPT and everything. The companies have built it and now they have saved it and giving it to you. When you are using it, you are using it just like an API. Okay, so this is important for deployment perspective. It is important for if you are looking at your project and you view it as a futuristic product and you want to give it as a service for other people, it's always important that you save the model and give it to your even teammates or something, so that if they are working with it or interacting with it, if the model hampers or there's something wrong with the model, you still have your original files intact. Okay, just like a safety measure. And if you guys have used Chat GPT, you must have noticed if you start giving it a similar type of question back to back or sequentially, it won't give you unique or creative answers anymore. Even if you're trying to ask Chat GPT that code this thing for me, and then you want to make minor changes and tell him to, change this parameter, change the background color or something, the smaller task it can do well. But if you ask it to, now combine two web pages to a JSP code or something, it will fail there. That happens because when your model is learning too much of your previous data, the overfitting part which comes, so that is why you don't get a good performance. So it's always better that when you are testing it, when it's not finalized, save one versions and do it just like you are using Git. After downloading model, can my model use same hardware as used in Colab to run? No. If you have run it on CPU using Colab and you have saved the model, then you can run it on your local system. Even if you are training it with GPU in Colab and you are saving the model, you can run it without a GPU in your local system if you don't have a GPU. A lot of times if you're building OpenCV, working with OpenCV or image processing kind of projects, in that you need a higher GPU. But now, since you have trained it already on a GPU, your model is processed. Now you need not do any training part. The training part is consuming your resources, hardware resources. But what we will be doing later on, while using the web app or whenever you're using it for a mobile or web app, at that time you need not do anything on scratch with the model. You need not tweak with the original model. So you need not use GPU once again. So irrespective of what your hardware are there in the local system, if it's good with memory, you have more than 8 GB RAM and CPU is fine, then you can run it. It's good to go. Did I answer your question, Sabhagya? Okay.
Yes, what happened?
Yes, sir, it's fine. Any other questions, or should we move to the web app part? Okay, I take it that you guys have no questions as of now, and we'll move to the web app part. Great. So you can use any ID of your choice. Here I'm using VS Code. Okay. Now, before I say what I'm doing here, there are a lot of ways. Just like I said, you can use Streamlit. There is another library called Gradio, and a lot of different ways in which you can create your web app. But I find this is the most simplest way of creating a demo version of your project if you want to do it real quick. Okay. And so what we'll do is, let's take a look at the web interface first. Whatever features we had, we are taking it as a user parameter. For home planet, we had 3 values, right? Europa, Earth, Mars. Then cryosleep is a Boolean value, whether it can be true or false. So we took it as a checkbox. Then there is which spaceship side you want, port or start port. Okay. Then the passenger age is a slider. Okay. Then whether they are opted for VIP treatment or not. Then the destination, where they want to go, Saturn, Uranus, Moon, Mars, and the name of the spaceship in which the passenger is traveling. This is the user interface which we need to create. Okay, let's go to that part first. So don't worry about focus from code line number 12. Okay, you have to create a main function. Okay, you have, before that, obviously you have to import Streamlit library. If you don't have Streamlit installed, then you can use pip install Streamlit and you can use it. You also have to make sure whether it is compatible with your current scikit-learn version or not. If you're downloading the most latest version of scikit-learn, it might not work well with Streamlit. Ensure that you have scikit-learn version 1.2.2. Okay. If this is one of the errors you might get while doing it locally on your system. So keep in mind to check whether your scikit-learn version is 1.2.2 or not. Okay. Then in the main function, we'll create our web page. We are using the title function to give a title to the name to our web page. If you want to insert emojis, this is how you can do it. But not all words have emoji. You need to check whether it is present or not. Okay, and then we'll create a home planet variable. Then we have to, this is a drop down option. So we'll use select box. What is the name of the menu? You have to give it as home planet. And here you can put you can just directly put an array of a list of values, that is Earth, Europa, Mars. Or if you don't know how many values are there in your data set, then you can use df home planet dot unique. Ensure that you have fetched your data set previously and your data set is in the same directory as is the app file. Okay. Then we have a checkbox for cryosleep. Spaceship side also we have a drop-down box. Passenger, we are using a slider. Our age limit is between 88 to 55. And by default, we want to show 30. Okay. Then we are using a checkbox for passenger VIP and for destination also. Similarly for spaceship. Now, in these many lines of code, we are done with, we have created this part of taking user inputs. Okay. and then we'll go to the predict button. Once we have taken all our user input values, now we want to work on the prediction. What is going to happen when we click on the predict button? So when you're going to click this predict button, all these user input values which you took, consider it as a form of a dictionary. Okay, it will take it as a dictionary. Home planet is the key, your value is Europa. Excuse me. Spaceship side is your key, your value is port. Okay, that is how a dictionary is created. Okay, now you have to convert that thing to a data frame, because now this is a new data for your model. Just like we were testing the model with the test data, like similarly we have to use this new data and make predictions from the model which we trained earlier. Okay, so this new data has to go through similar process of data pre-processing so that it is in a suitable format that can be used by our model. Okay, that's why, okay, this is first how we created it we took it as a dictionary. We are converting the dictionary to a new data frame. Okay, then for the non-numerical values, that is string values, we have to again encode it into numeric type. That's why you're using label encoder, and we are using it on home planet, spaceship, site, destination, spaceship, everything. And once our encoded vector is ready, we are using it for prediction. So the model here, we are not training any model anymore. Once the predict button is clicked, you can see here st.button. When predict button is clicked, this is what is going to happen. And we are going to make the prediction directly from the model. It no longer needs any training. Okay. And it will call the predict function, and you are going to create pass the new user inputs which we have collected. And then we'll have two results, 0 or 1. That is successful or not successful, whether they are transported to the other dimension or they are not. Okay, and if the first prediction is true, then you get a passenger is successfully transported message, or if not, then it's not successfully transported. Okay, now to run this, go to your terminal and write streamlit run app.py. Okay, so you'll get this web page which you have created, and you can give your whatever values you want to. Okay, let's bring the passenger age to also VIP passenger moon predict. The passenger is successfully transported. That is the message you'll get. So it's so easier now to explain your project. You just have to explain your problem statement. You can tell what all features you took and how the model is predicting. You are also getting a benefit of your IP rights, like no one is able to go through your codes. You don't have to share your code anymore to explain your project. This is a demo of what you built. Okay. And the problem which I initially told you here about class imbalance, because we have a lot of true data, that's why our model has a bit overfitted. So now it is going to predict more, the probability of predicting true has increased. Okay, because of the overfitting. So whatever values you are going to give, it's going to give you a true result. That's why it's important you go back and fix the class imbalance problem and come and check it. Then it's going to give you a, and here it's very difficult because you have so many parameters to find out the exact combination which is going to give you the false message is very unlikely. So you might try in this also, it might give you a false result. I haven't tried that much, but you can try. Any doubts in the Streamlit code?
No doubt. Very good. You can ask to ma'am.
Are they unmuted, sir?
Yes, yes. Unmuted. You can. Kuldeep, are you getting?
Yes, sir.
Okay.
Then that's great. And I hope I can. Yeah, Ibrahim, I have shared the code. Okay, for the Streamlit. After the session, I'll create a GitHub repository and I'll share the link to sir. He'll mail it to you, everyone, along with the PPTs and everything, so you can follow through it clearly. You can also
Thank you,
get this.
ma'am.
Okay, so Vagya has a question. Why I put 30 in slider? Here I put 30 because in the slider, the default age value which I want to display is 30. Now, if I refresh this page, you can see always when the page is reloaded, the default value of age is 30. Everything has certain default values. For checkboxes and everything, it takes the first value as the default value. But for passenger age, for the slider option, it doesn't happen. That's why I mentioned it. Okay, and for the people who are asking for code and everything, after the session, I'll create a GitHub repository and you'll get the recording of the session along with the slides and everything. And if you want to collaborate on projects or if you want any guidance in your projects, if you have any cool project ideas which you'd like to build together, then you can always connect with me. My email address and contact details are here. It will be very exciting to connect with you and build some projects, cool projects.
Many students are there from abroad. Those who have joined from South Africa, also one of the PhD scholar has joined. Whether he's here or not,
Yes,
I don't know. Okay.
yes, sir.
Sure, definitely. Okay, you can contact me or to Smriti and Nayak ma'am.
Yes.
Okay, I've already shared on Google Form for the today's session's feedback. So there I have written that in future you want to collaborate in this particular domain. What Smriti ma'am told to you. Okay, related to machine learning and deep learning, generative AI, like that only. Whatever areas are there. Okay, so just fill the form with your Pragya and Kisa. Can you share the Google form in chat box?
Okay. So meanwhile, I have a question from Subhashri. In medical data, how we can manage the missing data? Subhashri, it really depends on what data you're talking about. Okay, what is the data type? What are the type of values the data, the column or the feature contains? If you have a very specific doubt, then you can connect either through my email address. I need to take a look at the data set. Otherwise, I won't be able to answer your question appropriately.
Any questions?
Hello, sir.
Yes, Suvi. Connect. Suvi.
Okay.
Yeah.
Good evening, everyone. So, Mom had promised to say something about the problem statement because this project we've worked on, I actually don't get what we are trying to achieve. Like the columns we dropped, the features we chose for training, and all that. So I wanted you to
No,
talk about it.
to answer your question, this was just a fun project which I intended to show you to explain how the entire project building thing from scratch, from problem statement to the deployment works. Here, we just wanted to, the dataset contained information about a spaceship, group of spaceships which were traveling. There are some passengers in it. The mishap happens, and the spaceship, we lost contact with them. So for some celestial events, this is a hypothetical and imaginary situation. Okay, some passengers got transported to an alternate dimension, and some passengers were able to reach back to their home planet. So that is what we are trying to predict using all these features which contains data about the passenger and the spaceship, whether we want to, what type, which passengers were able to reach back to their home planet, or which passengers got transported to an alternate dimension. Okay, this was just a fun project which I did so that it's engaging for everyone. Okay, this is for a broader classification. You can consider it as a classification problem or a prediction model. The similar kind of things you can do for sentiment analysis, where you are trying to predict emotions of different people, or you want to classify movie reviews or product reviews from Amazon, Flipkart, or eBay. Okay, so this was just for a fun activity. I chose this thing. This has no relevance with anything practically happening around. Okay, and if you want to go for a practical implementation of this thing, you can look into the areas which I said, sentiment analysis or movie reviews or those kind of things. Okay. Subhi, was I able to answer your question?
Yes, Subi.
Yes, ma'am.
Okay.
Any other queries are there? You just check Smriti once.
I have another question from Avanish. Ma'am, where MLOps comes to play? See, MLOps or ML operations is again a very wide field, just like machine learning itself. Okay, when you are working on deployment, when it's working on a real life scenario, you are having a lot of other frameworks which are coming into play. Okay, just like now we are working on a local system and a cloud collab server. It is so easy to transfer files between these two things. But when you are working in an organization, you will have Git repositories, you'll have a different production environment, development environment, and testing environment. Whenever you are making any changes, or when you are trying to install, implement and send a feature, finalize a feature, it has to go into all the places correctly. There, cloud comes into play, DevOps comes into play, there's Jenkins, there is continuous integration, continuous development. So ML operations is also like a similar, or it comes under the same Venn diagram of your DevOps. Okay, it is how you are, whatever you're doing on your local system, and how you are deploying it on the server, on the internet, out available for everyone. Okay, that the way of saying it is just in one line. It's very simple, but there are a lot of things which comes into play. If you are using clouds, like services, like if you are using Azure or you are using AWS for training, you can see there are a lot of other pipelines you are using during deployment. Okay. To answer your, I hope, Vanish, I'm able to give you some clarity to your question. Yeah. Okay. And there's another question by Bhavani. MLOps is hard or easy? It depends on how much time, efforts, and interest you're putting into it. If you have interest and time, and you're putting it in putting in the efforts, and you're lucky enough to find a good training content or a good resource to learn from, then it's going to be easy. Ankita has a question. If I can recommend some MLOps tools. That depends again on what type of project you are doing and how much you want to scale it. Okay. If you are looking for a smaller audience, I think there is also an option to deploy your Streamlit idea. Sorry, sorry, I just read Avanish question. I said idea. If you are working on a smaller projects and you have created a Streamlit app, you can deploy it. Streamlit has its, I think, own platform for deployment. Or if you are creating for smaller projects, this is what I'm talking about. Okay, if you are creating any other web app using HTML, CSS, there are so many other platforms like Heroku, or you can get your own domain. Yes, and you can launch it. Okay, that depends. That's why I said it depends on the scalability of the project. Sure, Avanish, we can connect through WhatsApp or LinkedIn.
Mama, I have one question.
Yes,
Yes,
sure.
yes.
So here you used label encoding, but you had also talked about one hot encoding. So
Yes.
why did you choose label encoding here, and which is the best to use, and when do you use it if you're to choose between the two?
I chose label encoder here for basically two reasons. My data set is a small data set, and I am already aware of what type of unique values are present in each column. Okay. Just like I knew what values for, there are 2-3 columns which are containing string values. Just like the home planet has 3 values: Europa, Earth, and Mars. Okay. Then I know what are the possible values present there and how many values are there. And what the model, second thing is so it's easier for me to just label each value with a numeric value. I have Earth, I can label it as 0. I have Europa, I can label it as 1. I have Mars, I can label it as 2. Okay, this because I already have an idea about how many unique values are there. Okay, and secondly, it also depends on the type of model which you are using later on. Okay, there are certain models like random forest classifier supports both one-hot encoding as well as label encoder. But since this is a simpler project and a small scale project, you can go with label encoder. Okay, there are a lot of statistical and mathematical approach to also analyze whether you should go for one-hot encoding or label encoder. But simply when just considering when you're working on projects, just go through two things, whether it's compatible with your model or not. You need to go through the documentation of your model, what kind of model, what kind of data is your model ready to receive. Okay, if and also if your data set is larger, you have a lot of categorical values, then it's preferable you can go for one-hot encoding. But there is no hard and fast rules that if this is the criteria, then you're going to use label encoder, or if it's not, then you're going to use one-hot encoding. It all comes to you. The more you use hit and trial, the more projects you on implementations you do, you'll get an idea. There is no hard and fast rules for this.
Okay, okay, one last question.
Sure.
Also, when you're dealing with null values, if there's a feature you want to use but it has a lot of null values and you do not want to drop it, if you're imputing, okay, sometimes they use the mean or the median or they fill zeros in the null. So again, under what circumstances do you choose to either use the mean or the median or use zeros? Does it matter what you use and why you
Generally,
choose to
it
use
doesn't
any of them?
matter. What difference it will give if you are using mean, median, or mode is that you might get a slight change in your model performance. Okay. And also you need to, now I only showed you one matrix for evaluating your model, that is accuracy. Then there was another part where I mentioned there is a confusion matrix, okay, where you have true positives, false positive, true negative, false negatives. Okay, you need to try going with mean once and see what your value of confusion matrix is. Okay, then go with median, it's and see how it changes. Usually it doesn't give a much difference. Okay, it will not give a difference if you are using mean, median, or mode, but it will give you a significant difference if you're dropping it out entirely. Okay. I think that's what I'll say for this. And again, depends on what your data set is, whether it is text, whether it is a large decimal value or not. Okay, whether you have sufficient data to find out a appropriate mean, median, and mode. Because if you have a lot of null values and we are just replacing every null, like suppose you have total 50 entries and there are only 20 values present, rest 30 are null. Okay, and if you'll just go with mean of it, then you'll have too much of you'll face the problem of redundancy. Okay, and even if you are missing those filling in the missing values or none values, your feature importance will change. Okay, how the feature is contributing towards your end result, that will be affected. Okay, so in that case, maybe you can segregate it. You can take 1/3 of the values for use it with mean. You can take 1/3 for median, take 1/3 for mode. Or in that case, you can choose, there is a way of doing resampling it. Okay, while resampling it, it will create, it's like creating dummy data from the existing data. It will create more similar type of data and fill in the missing values. Okay, so it all depends on what type of data set you are dealing with and what you are trying to achieve. Okay, Subhi?
Somebody asked
Yes,
about the
ma'am.
random values. Can you also input random values?
Yeah, if you want to input random values, go and check the correlation matrix once. Okay, you have to see how what is the correlation of your feature with your target value. If it is the correlation is less, as in it is not contributing much to your output results, then maybe random values won't affect your model performance. But it's never advisable to do that if your data is very much distributed. Okay, there is no once you plot the graphs, there is a box plot, there are so many other plots. There is also, just a minute, because you asked this question, I'll show it to you. I have it handy. Shit. Okay, you can see how closely the data values are connected with each other. Okay, whether they are sparse or they are close together, there are so many plots which you can use to see what the data distribution. It really depends on that data distribution. If it is scarce, it is sparse, it is yeah, Avnish is also right. The chances of outliers also increases in random value. That's why, but that again depends on what is the feature importance. If the feature is not really contributing to your target value, then it doesn't impact it much. We need not deal with that feature itself. Okay, there are you should read about feature importance, and you can do it using random forest classifier also. It's all when you have more than say 10 features, always check the correlation matrix and try to find out feature importance. What will happen then, you can, instead of 10 features, you can only focus on 5 features which are actually contributing to your target value. Okay, and use it for model training. That will increase your performance. And random values is always never a good idea until and unless, that's the only exceptional case, if it's not contributing relevantly to your output, then it doesn't matter if you're using random value or not. Okay, I think I've answered your question regarding that. And someone else also, Saubhagya had a question that is there any way to bypass hardware limitations in reinforcement learning? For example, I want to create advanced NPCs with human-like behavior, and it need to learn from environment, so I can't use clouds. I need my own hardware. See, there are for models which have a hard and fast rules that it needs certain GPU and it needs a TPU or something. There is some hardware limitations, and if you don't have it, there is only one way left. Like for your case, you also mentioned you can't use clouds. What you can do is maybe collab, find out in LinkedIn there are certain labs which will give you access to their hardwares. There are labs, research labs in IITs and other colleges who are generally open towards such proposals. And since it's a very good idea, or it's a very advanced topic you are working on, they might also like it. You might get a chance of collaboration or a summer internship as well. That's how you build connections, networking, and work it out, right? So there is generally no other way to bypass hardware limitation. The only hardware limitation which we are able to tackle now is the GPU thing, which is available on cloud. That too, after it's a lot of those services have restrictions. You don't get it on basic plan, or there is a limitation on how much time you can use it for. Like in Kaggle, we have that restriction. So, but for your situation, I'd suggest the best thing out is reach out to a research lab who's having those systems, and maybe you can get access to that, or maybe you can transfer your data if it's not much private and you're not worried about your IP thing. So you can give that. The best part here would be collaborating with it. Ma'am, is that we can use a pre-trained model and fine-tune the model to get the expected result if there is hardware limitations? Again, depends on what you are trying to achieve. There was a similar project which I was working on, which I guess you guys must have heard of, where you are working on sign language interpretation, where you are showing ASL and the model. You build a model which is able to identify those sign languages. Okay, so for that I faced a hardware issue. So what we did is TensorFlow has certain pre-trained models which we can use it. But the pre-trained, what will happen is that the response or the model output won't change much, because you cannot retrain it or fine-tune it much. There is less flexibility on how much fine-tuning you can do. But if like you are working on LLMs, considering that when you have Llama or GPT models, there are different ways of fine-tuning. Okay, so it depends on which model you are talking about. Okay, and that's how you can figure it out.
I think we stop it here. Okay, anyone wants to do some projects, okay, directly you can contact to ma'am or to me. Okay, anyhow, you are going to contact to ma'am or to me. We are going to project together because ma'am is collaborating with me for last 3 to 4 years. Okay, so this is the thing. I think any questions later we can discuss. I think fine. Smriti, if you can stay, then it's good. We have one culture program from 10 minutes.
Yes, I can.
Okay, 2 dance recordings are there. We're going to play. Devanshu, are you there?
Sure, sir.
I think we have to go out of this Zoom ID. Then again, we have to join because separately we are recording the sessions to upload in YouTube. So again, we have to join. Fine. I'm ending this session. Next, we'll join soon.
Okay.
Thank you.
Okay, sir. Thank you, everyone.
Thank you. Thank you to all. Thank you, Smriti.
Thank you,
It's a nice
ma'am.
session.
Thank you, ma'am. Thank you.